Hello everybody, my name is Lucas Niño. I did, for my disease report, tetanus. It's formerly known as tetanus. It's also known as lockjaw given its symptoms, and yeah, it's formerly known as Clostridium, or its infective agent is Clostridium tetani. Its characteristics are spore forming, gram-positive, it's slender in shape. You can see it from the image. It's an anaerobic rod. It's also referred to as having a tennis racket shape. And it was first discovered in the 5th century BC. You also have recordings from Egypt in the 1500 BC. You also have Hippocrates. He writes about it in his book on epidemics. And he accurately describes the symptoms of stiffness and stiff neck, and so you also have, it wasn't until the late 1800s that the scientist Arthur Nicollier discovered the toxin itself. The transmission occurs through contact between an open wound with soil, dust, and manure that has the bacteria spore. The spore actually develops into a bacteria once it enters through the body, and so any object that is contaminated with soil, dust, or manure can, when it causes a cut, it results in infection. The pathology of tetanus affects the central nervous system. It most notably affects the peripheral motor end plates, the spinal cord, brain, and sympathetic nervous system. As the spores germinate, the toxins are produced and they're disseminated through the blood and lymphatic systems. The toxin binds to nerve endings, and so it becomes necessary for entirely new nerve endings to grow, resulting in a long period of recovery. It can take up to 3 to 4 weeks for someone to recover from tetanus, and it can even last some months. The symptoms and types of tetanus, there's 4 types of tetanus. There's generalized tetanus, localized tetanus, and cephalic tetanus, as well as neonatal tetanus. In the image, you can see the symptoms of trismos or lockjaw. You have the stiffness of neck as well, difficulty swallowing, and the rigidity of abdominal muscles. There's also the potential for elevated blood pressure, temperature, and sweating, as well as episodic rapid heart rate. And these episodic rapid heart rates can span over several minutes at a time. The muscle spasms themselves can ultimately lead to broken bones, or potentially lead to broken bones or broken spine. And it becomes fatal when the spasms lead to respiratory failure, which then leads to the individual going into cardiac arrest and then eventually dying. Localized tetanus usually precedes generalized tetanus. It's less common compared to generalized tetanus. Generalized tetanus, again, is most common. It has 80% of cases throughout its history. Localized, however, precedes. It's less fatal, and the muscle contractions typically occur around the area of the infected wound. Cephalic tetanus is contracted from the injuries in the head. This is also a rare form of tetanus. Currently, probably the most fatal is neonatal tetanus, and this occurs with infants within 4 to 14 days after birth. The infant initially, within the first couple days, within 3 days, loses the ability to suck or swallow, and it's typically contracted as a result of when the doctors are delivering the baby and cutting the umbilical cord. If they're using unsterilized equipment, then that can lead to an unhealed umbilical cord cut and unhealed stem, and so the baby contracts tetanus. The baby can also contract tetanus from the mother. The mother can transmit the disease. This is the only way that the disease can actually be transmitted from person to person. Otherwise, it's always through encounter with the environment, through a wound. From the historical perspective of tetanus, it was Kitasobo Shibasaburo was the first scientist to isolate the tetanus organism from a human in 1889. He, among other scientists, were testing how animals reacted to the bacteria, and so they were injecting animals to test infection. They found that bacteria was neutralized with specific antibodies. Edmund Nocard was also a prominent figure in relation to tetanus. He demonstrated the protection from a passively transferred antitoxin, giving humans passive immunization, and this was significant for World War I and World War II, because as you know, in World War I there was trench warfare, and so the potential for soldiers contracting tetanus in these circumstances was very high. However, given Nocard's contribution and discovery of passive immunization, it was given to the soldiers, and there was 500,000 recorded wounds, and only 23 resulted in cases of tetanus. And so it shows the impact of his discovery. The actual vaccine was developed in 1924, and it was also widely used in World War II. In 1990, you had 314,000 deaths from tetanus, and it was ultimately reduced to 38,000, resulting in an 86% reduction, also indicating the effectiveness of vaccines, specifically in lower developed countries, less developed countries, who require that aid and that availability of the vaccine all the more. Between 2009 and 2017, there was 264 cases, 19 deaths were resulted, and 3 were from neonatal. Other patients from these 264 cases were above the age of 55, and it's not necessarily because they were older, but because they weren't receiving their booster shots that is required in order for an individual to retain immunity. The treatment and cure, the vaccine was developed in 1924. It was combined with diphtheria toxoid. The image shows the different age groups that received the different types of vaccines for tetanus. It's significant to notice that among children, there's a 93% coverage of the vaccine. So that's optimal and a very good number. However, as you increase the age, as you look at the older age ranges, 19 to 49, the total coverage is reduced to 62.6%. The percentage further drops for adults 65 years and older to 57.7, showing or indicating that the older population isn't getting as much of the booster shots that is required to retain immunity. The toxoid itself functions again by producing antitoxins which neutralize the bacteria. Once again, it requires a booster shot every 10 years. The toxoid, since it's inactivated, it contains no living organisms, therefore it cannot replicate and thus requires a booster shot to retain immunity. Concerning recent outbreaks, there hasn't been any, obviously, between individuals. There's no contact transmission, and so these outbreaks were from natural disasters. You see an earthquake in northern Pakistan and Kashmir in 2005, which resulted in 139 new cases of tetanus, and the tsunami in the Aceh province in Indonesia in 2006 resulted in 106 new cases. And this sort of indicates the importance of upkeeping the immunization in all places of the world, especially the less developed areas which don't have access to these vaccines, because it's the best way to prevent outbreaks. And so tetanus today, the WHO reports as of 2019, there's a total of 14,751 cases worldwide. In 2011, significantly, there was 72,600 infant deaths from neonatal tetanus. The third world, less developed countries, which are at the greatest risk, are South Asia and Sub-Saharan Africa. 82% of cases worldwide are derived from these areas. and it's specifically due to unsanitary environments, especially when delivering babies, that results in many neonatal cases. The WHO has an initiative known as the Maternal and Neonatal Tetanus Elimination. They admit that tetanus cannot be eradicated in the same manner as smallpox or polio because the spore is always in the environment, in soil, manure, and dust, and so the best way to solve the problem of tetanus outbreaks would be to promote hygienic deliveries, specifically in these less developed countries, and immunization for mothers, as well as cord care practices. Immunization for all is what is ultimately going to lead to the elimination of tetanus, even though it won't be fully eliminated. However, it's the best path forward in reducing the total number of cases and risks. Thank you.